All right, let's get into two-way tables. So what two-way tables are is they're an alternative to Venn diagrams. And if you honestly want my opinion, I wouldn't even bother teaching Venn diagrams if it wasn't for the case of they just, they want you to draw Venn diagrams in exams. I always prefer two-way tables. I don't know, man. They just take the thinking out of it. Like with a Venn diagram, you've got to think, okay, where is the A or B and stuff. Like, oh, where is A and B dash? And you've got to think, okay, all right, well, it's inside A, but I don't want it inside B. All of that, yeah? I mean, it's not hard once you get it, but, there's some effort involved with it. What I now want to look at, and bear with me a second. I will now want to show you how to do a two-way table. And what we're going to do it by looking at a question we've already done. Bear with me where I put it. Let's go back to this question. So if I get the snippet. Hopefully you can kind of see that. Don't watch on your phone. It's going to be too small. Okay, so do you remember what it says? Like there's 30 pupils in a class and you got the brown hair and stuff. So you do one for obviously girls and you do one for brown hair. The way you do two-way tables is you're going to draw like a... Whoops. You're going to do a two-way table, okay? And on the top row, you're going to do do girls and not girls, okay? And across the here, you're going to take the other one. So brown hair and not brown hair. By doing this, what you've just done is, you know how this is like, we've got 4 areas here. Well, can you see? So 2 is the one which is girls and brown hair. So this is your area 2. Area 1 is the girls which don't have brown hair. This is area 1. In area 3, they have brown hair, but they're not girls. And finally, number 4, they're not girls and they're not brown hair. So you see, you've actually made a whole nice little area like this. But here's where it gets better. When you know you can start just putting in the numbers like this. So if you remember earlier, we had, so this was 5, this was 9, this was 6, and this is 10. So you would literally put in the numbers here if you knew. But let's just have a look at the question. I'm going to show you an alternative way. So do you remember we had to figure that kind of stuff out there, yeah? Let's have a look here. Firstly, in this two-way table, we're going to do totals here, yeah? So what this square here is, you'll notice there's actually 5 squares on the outside here. And it all depends on what row it is. So this is the total number of people who have brown hair. This is the total number of people who no brown hair. So we've actually got totals table. Before, when you have it on this and you get told, oh, that there's 14 pupils are girls, you don't have anywhere to write it. But in this one, you're like, oh, hold on. This is the row for all the total girls. You can put 14 there. Now let me clean this mess up a little bit because I've put loads of lines there. Yeah, this is fine. Total. And this, by the way, this bottom height, remember, that's every single person. So let's have a look at how I do this. Okay, there's 30 pupils in a class. Okay, 30 total. I know that these two have to add up to 30, these two have to add up to 30. 14 of the pupils are girls. So that means 14 are girls. That immediately tells me that 16 must not be. So literally this row has to add up to get to 30. So that means 16 is not girls, just like that. Okay, 11 have brown hair. 11 goes into here. That's the brown hair total one, which means 19 are here. Now, as soon as they tell me 6 of the pupils have brown hair, so I know I'm going to put it in here, and they're boys, they're not girls. That means 6 goes here. Does that make sense? Yeah. I've actually cut out the question of that. Oh wait, no, we'll get that in a second. I can now fill in all these numbers so quickly. So I now know that these two, this one and this one, have to add up to 16. So that's 10. But I also know that these two have to add up to 19. So that's 9. And finally here, that's 5. I can fill it in like that. Just like that. Now, let's have a look at the 2-part questions from before here. So how I would do it from this. Maybe I'll go closer actually. Pupil is selected at random. Pupil is selected at random from the class. So that's everybody. So this is your whole class. 30. And it goes, it's a girl. So I know immediately I'm looking down here who doesn't have brown hair. So it's this one. 9 out of 30. Can you see that? You can do 9 out of 30. Let's do this one here. Girl select a random at class. I mean, it's virtually the same, to be honest. Should be kind of... I always prefer this way. As long as you can do it. Ideally, you want to be able to do both anyway. A girl is selected at random. I know there's 14 girls, so I know this is going to be out of 14. Probably she has brown hair. Well, okay, where's the girls with brown hair? There's 5 of them. There you go. 5 out of 14, okay? So it's an alternative way of doing it. Now, the one drawback of two-way tables is it can only be done for when, if you're doing a diagram which has 2 things, you know, so for example, the burger and the chips. If you had the burger and the chips, you would just literally do A dash, B dash. Can you see you get 4 squares which represent all the 4 areas in here. But if you have another circle, you cannot do this because it's only got, you know, you can only put one thing across the top and the second thing across the side. So that's the big limitation it has. Apart from that, I love them. I think they're much better. Does it matter which one you do? No. And to be honest, actually, as I've been explaining this, I'm like, you know what? Venn diagrams aren't bad either. So, okay, shall we do another question? Let's do example 4. I like example 4. Oh yeah, good. Here's one. Let me get a bigger one of that, just in case, just in case. Okay, so two-way table, right? You notice in any week she goes to a maximum of 2 evening classes. She either goes to a dance class, to a knitting class, or both classes or neither class, okay? So really the 2 things involved here is whether she goes to dance or knitting. So the way we're going to do our two-way table is, well, let's first think the Venn diagram will be like this, right? D and K. So remember, you've got to treat each thing separately. So we've got to look at D and not D, and K and not K. Dance and not dance, or knitting or not knitting. So when you do your two-way table, let's put dance here, let's put not dance here. I want another row for total. Knitting, not knitting. It wouldn't have mattered as well if you did the knitting across the top either. Okay, so let's have a look. So we're dealing with probabilities. So whenever you're dealing with probabilities, naturally the total in the bottom right corner is 1 because all probabilities add up to 1. So let's have a look. The probability that she attends a dance class is 0.6. There you go. This is the total of dance classes, 0.6, which makes her probably not going 0.4. Probably knitting class is 0.3, which makes this 0.7. probability she attends both classes. So can you see what we're looking for here? That's this square, which is 0.15, because this square is the one which represents dancing and knitting at the same time. She's gone to both. Well, as soon as we have this, the rest of it just fills in so nicely. So for example, this one's got to be 0.15 for that to add up to 0.3, which now, and it doesn't matter which one we look at, so we could look at maybe down here. So we need 0.25 for these to add up to 0.4. And, you know, this one needs to be 0.45. A little bit of hesitation there by me, okay? So, and you can now see with that number, these two add up to 0.6, but also at the same time, that adds up to 0.7. And there you go, okay? So it's very easy once you get the hang of this to set up two-way tables. Let's actually look at the question bits here. Okay. Find the probability that she attends at least one class. Well, remember, all we have to choose between are these four squares. We just have to say, okay, which of these four squares represents at least one class? Well, this one definitely does, because that's both classes. Also, does this one, because we really want everything in this row, because everything in this row means she went to the dance class. We also want everything in this row, because this is the knitting class. So we want that too. I mean, we'd overlap with that, but we've already picked that. So can you see it's this one, and this one, which we want to add up to. They're the, because it's these four. These are totals, by the way. These cells outside are totals, but these are the four possibilities. These totals just help us in different ways, setting up the table. But the probability that she attends at least one class is 0.15 plus 0.15 plus 0.45, which equals 0.75. And there you go, the answer's done. Let's clear some stuff up. Let's look at the next one. Remember, we're just going to be picking out these four which one we want. That's what it always boils down to. Okay, like which ones do we want? She attends exactly one class. All right, well, let's have a look at this. The first question is, do we want this one? Well, no, she's attended both. So nope, we don't want one. Exactly one class. In here, she's attended both. This one is good because she's attended knitting, but not dance. That's one class. This one is good. She's attended dance, but not knitting. And over here, this is not knitting, not dance class. She's just literally, you know, she's had a very chilled week. She's not done anything. So it's just those two. So you add up 0.15 plus 0.45 equals 0.6. There you go. That's how you do the probability for that. Hopefully that makes sense, guys. Okay, that is two-way tables.